In this video, we are going to find the tangent to the curve x to the 2/3 plus y to the 2/3 equals 4. At this point, 3 square root of 3, 1. So the way we are going to do this is using implicit differentiation. We already worked with this curve in a previous video, but we are going to repeat the computation just to compute the slope of the tangent. So remember, we take the derivative respect to x of both sides. Okay, so the right hand side is constant, so the derivative is 0. On the left is 2/3 x to the negative 1/3 plus 2/3 y to the negative 1/3 times dy dx. And it is essential that we remember that y is defined here implicitly as a function of x. That's the reason why we get dy dx here. If we forget this, then the problem will be impossible, okay? So now what we have here is 2/3 x to the negative 1/3 plus 2/3 y to the negative 1/3 dy dx equals 0. We can simplify the 2/3 and we get dy dx equals minus x to the negative 1/3 divided by y to the negative 1/3. Or if we want to write it a little simpler, we can put positive exponents and just flip numerator and denominator. We could even write minus y over x to the power 1/3. Now, the advantage of this expression is that now if you give me a pair xy, I will be able to compute the slope right away. Actually, we were given 3 square root of 3, 1. So dy dx evaluated at 3 square root of 3 is minus. And then here I put the value of y, which is 1, divided by the value of x, 3 square root of 3, to the power 1/3. And this is going to be the value, this is the slope m at that point. Okay, here it would be, I didn't do it right away, but I should have done it. So let me do it here on the side. Always check that the problem is well posed. Okay, what I mean by that is that the equation is satisfied. So for the equation to be satisfied, I need 3 square root of 3 to the 2/3 to be equal to 3. Okay, so that means 3 square root of 3 square equals 3 to the power 3. And this is 3 squared times 3, which is 3 to the power 3. So we are good. This means the point is on the curve. Okay, this is something important to check because it may happen that the problem is not correct. All right. So that being said, now we can write the equation for the tangent, which is mx plus b, or we can write it in the form y minus y0 equals mx minus x0. Okay, probably the second one is easier. So we are going to have y minus 1 equals minus 1 over 3 square root of 3 to the power 1/3 times x minus x0, which is 3 square root of 3. And we can simplify this and see what we get. The alternative is to just write here y equals minus 1 divided by 3 square root of 3. There you go. to the power 1/3 x plus b. And then use that the point is 3 square root of 3, 1. So y is equal to 1. And then x is 3 square root of 3. And then we have b there. So b is 1 plus 3 square root of 3 to the power 2/3. Okay, I simplified there. And then we can write down the tangent. It's simply this quantity. So the slope times x plus 3 square root of 3 to the power 2/3 plus 1. Now, one thing I didn't notice before, but I noticed now, is that 3 is the square root of 3 to the power 2. So I can write 3 square root of 3 as square root of 3 to the power 3. So there is a nice simplification there. The slope becomes -1 divided by square root of 3. Okay, so then I can go back to my computation and just write this simpler expression and apply the same trick here, because this is square root of 3 to the power 3 raised to the power 2/3. So that there's a lot of cancellation there. That is 3. So it looked very complicated, but in the end, it's just -1 divided by square root of 3 x plus 4. And this is my tangent. Okay. One thing we can do, let's plot it, see how this curve looks. So we can, this program here is, this app is GeoGebra. So we can plot x to the power 2/3, then plus y to the power 2/3, and then this is equal to 4. And here we have our curve. Okay, so this is how it looks. And now let's plot the point where we are working. So the point A, which is equal to 3 square root of 3, 1. Oops. There you go. So here is the point where we are trying to find the tangent. And let me plug in what we found. Let's see if the computation is correct. So y equals -1 divided by square root of 3. Okay, x plus 4. There we go. So this is, with this method, we can, for any point of the curve, we can find what the tangent is. Now, once we have found this formula for this formula here for the slope, we can do as many points as we want. Okay, for example, we could decide to do -3 square root of 3, 1. Okay, this would be another problem to try. We could also do 2 square root of 2, 2 square root of 2. In this case, the slope becomes very, very easy because it's -y divided by x to the power 1/3. but because the two components are equal, then this is, sorry, the minus is outside. There we go. Then the slope is -1. Okay, so we have y equals minus x plus b. So we have that b equals 2 square root of 2 plus 2 square root of 2, which makes 4 square root of 2. And the tangent is -x plus 4 square root of 2. We can check this. So for instance, in this case is y equals minus x plus 4 square root of 2. And we see that, in fact, the new tangent that is plotted here touches, it's a tangent at the point where both coordinates y and x have the same value. Okay, so we were working at 2 square root of 2 to square root of 2, that's the point. So you see that this is like a machine. We can do as many as we want. I leave here for you a few problems if you want to try them. So you can find dy dx for the following. For example, 4xy equals 3, sine of x equals cosine of y, and 3 e to the xy equals the secant of y.